Good morning, MSc student. Today we are going to discuss MSc final year group theory, unit first. In this unit, we have discussed element of symmetry, and symmetry operations, matrix representation of symmetry operations, and different symmetry operations that are associated with the molecule. Yesterday, we had discussed matrix representation of symmetry elements of water. In this, first of all, identity operation. No change. Identity operation does not bring any change in coordinates or the real structure or the original structure. Therefore, the matrix that is represented for identity, in this matrix diagonal elements are unity. 1 1 1. It is three dimensional. It is 3 by 3 matrix. Diagonal elements, it is a unit matrix in which diagonal elements are unity 1 and non-diagonal elements are 0. In C21 operation, where water is rotated by an angle of 180 degree through the axis passing through oxygen, and that is present in the plane of the molecule. In this, you can see as the rotation is carried out along the z-axis, then x and y coordinates will change, and there will no change in z coordinate. Therefore, in matrix representation, A11 diagonal element is -1 and A22 diagonal element is -1, while A33 diagonal element remains 1, as there is no change in z coordinate. In sigma Vxz operation, xyz coordinates will change accordingly as the reflection is carried out in xy plane, xz plane. Therefore, there is no change in coordinate x and z, while y coordinate will change, and therefore matrix represent of A11 diagonal element is 1, A22 diagonal element is -1, and A33 diagonal element is 1. In sigma Vyz, the vertical plane of symmetry in YZ plane, as the reflection is carried out in YZ plane, therefore there is no change in y and z coordinates, but there will be change in x coordinate. X becomes -x, and therefore A11 coordinates become -1, while y and z coordinates, that is A22, that is represented by A22, and A33 diagonal elements, that remains 1 only. Now, we are going to define the character of a matrix. What is character of a matrix? Character of a matrix is defined as summation of diagonal element in the matrix. In a given matrix of a particular symmetry operation, if we add diagonal element of the symmetric matrix, then what we get is character of that matrix. Character of that matrix. You can see representation of character at different symmetry operation is regarded as character table. If we represent the characters, what is character? It is summation of diagonal element for a given matrix of a particular symmetry operation. And representation of character at different symmetry operation is regarded as character table. As shown in this table, in identity operation you can see that summation of diagonal element is 3. Therefore, it is the chi, that is the character representation, identity follow by 3. And in C2 1 operation, it is -2 plus 1, that is -1. Then character of C2 1 operation is -1. Similarly, character of sigma v xz operation, it is 1 only. Similarly, character of sigma v yz, it is 1 only. As the summation of 3 diagonal element is 1 in sigma plane symmetry, and rotational operation has character -1. Now, character multiplication table. How can we draw multiplication table? In multiplication table, it is represented by the following example, and there it is example of water only. Now, the multiplication table of symmetry operations, we has symmetry operation of water at top of the table, that is identity operation, rotation operation, sigma v xz operation, and sigma v yz operation. Similarly, these operations are also shown in left end of the table. It is denoted in a column: identity operation, rotational operation, plane reflection operation. Now, these operations are multiplied by each other, and these symmetry operation, what is the result actually? What will be the result? Identity and identity, in it means 2 times identity operation if carried out on water. What will result? It will be identity. Therefore, it is represented by capital E, that is identity operation. And you can write the character of this table. In upcoming classes, we will draw different multiplication of tables of different molecules. Now, in second one, if I'm just discussing, or we just emphasizing on multiplication tables first column. In second character of the multiplication table of first column, it is if identity operation is followed by C21 operation. What will result? Identity is, there is no change. Therefore, it will be C21 only. Similarly, if sigma vxz operation is combined with identity operation, then what will result? XV sigma V XZ. Similarly, if identity operation is combined with sigma V YZ, then you will get sigma V YZ. This is the group multiplication table. It is multiplication table. Similarly, in second column, we will multiply the character that are shown, operation that are shown in far left end of the table to the C to 1 operation. Again, if C to 1 operation is combined with identity operation, you will get C to 1 only. Therefore, in second column of the multiplication table, it is shown C to 1 only. And if C to 1 operation is combined with C to 1 operation, that is 2 times rotation. Imagine the rotation of the water 2 times. First rotation of 180 degree, then second rotation of 180 degree. It is all 360 and it is nothing but the original structure or original configuration. That is the identity operation. Therefore, if we combine two C to 1 operations, then results will be identity operation. That is shown as second character of the second column of multiplication table. What happen if sigma Vxz is combined with C to 1? Then you will get nothing but sigma Vyz. Apply the operation on water. First you rotate and then rotate the molecule. When you will rotate the molecule, what you will get? You will get x and y coordinates will change, while z coordinate will remain same. If we apply C to 1 operation of water, then you will get what you will get? What coordinates will change? X and y coordinates. But z remains same because the rotation is carried out along the z axis. Therefore, there is no change in z axis or z coordinate. Now, after doing C to 1 operation, if we apply sigma xz operation, what will result? In sigma xz operation, you will carry operation in xz plane. What will change? There is a change in y coordinate. As reflection is carried out in xz plane, there is a change in y coordinate. Therefore, what will be the result? The result will be there is no change in x coordinate, it means it remains -1. There is no change in z coordinate, it remains 1 only. But there is a change in y coordinate. It means -1 becomes 1. Now you will get the matrix that is represent sigma Vyz. Therefore, sigma Vyz is shown in third character of second column of multiplication table. How beautifully you can draw a multiplication with the help of matrix representation. Therefore, matrix representation, that is a pure mathematics, is applied here to represent the symmetry operations of a molecule. Now, first of all, what you have to do, you just seen the matrix representation of this operation and then apply the second operation on this matrix and assume the change in coordinates. Then you will get, what you will get will be the result of multiplication of the two operations. In fourth character, what is sigma v xz? How I am getting sigma v xz? So then first of all, you just apply C2 1 operation. You will get matrix of C2 1 operation, that is shown here. Minus diagonal elements are -1 and 1. Now -1 x coordinate, -1 y coordinate, and 1 is z coordinate. It represents. Okay. Now apply the reflection in yz. There is no change in yz. यानी कि -1 रहेगा, 1 रहेगा. There is a change. -1 ही रहेगा. There is no change in z coordinates. 1 ही रहेगा. लेकिन there is a change in x coordinate. -1 become 1. -1 1 हो जाएगा और -1 रहेगा, 1 रहेगा. तो ये रिप्रेजेंट किसका आ जाएगा? एक्स वी वाई जेड मैट्रिक्स का. एंड एक्स वी वाई जेड मैट्रिक्स का रिप्रेजेंटेशन आया. इसका आंसर फोर्थ कैरेक्टर आपका एक्स वी वाई जेड ही है. तो फर्दर remaining 2 columns we will discuss in next class. Thank you very much.